Cool. Thank you very much. Thanks for having me, first of all. Yeah, thanks for creating such space, Alexei. I think it's a great community of people, and if you're not yet part of that, highly recommend joining. And yeah, thanks for having me here today. Super excited to talk about data-intensive teams. My name is Elias, and I'm from Olex Group, as Alexei mentioned. And yeah, let me quickly, like, if I can deal with my presentation. Yes, I can. I can switch slides. That's a great start. Let me quickly introduce Olex Group. It's a huge online marketplace. Uh, I would say lesser known. Some people say that this is one of the biggest internet companies that you don't know about. We are present in 25 plus countries and have like quite some monthly active users, and have lots of brands around the globe. And yeah, at the Olex Group, I'm leading search and recommendations for the European business unit. And as you can imagine, these are like two parts heavily affected by the data, and we can call them data intensive. And yeah, like in this talk, I'll be focusing on what this means, on our learning through the journey, and how we are thinking about that. But first, let's try to define what is data intensive first. And data intensive applications is actually a term, like I think firstly coined by Martin Kleppmann a couple of years ago. And like this is also a great book, by the way, highly recommended. So he's saying if data is a primary challenge of the application, then the application is data intensive. So quality, complexity of data, speed of data are biggest challenges, then it is data intensive. And in his book, he also exposes a couple of new architectures that arose from managing these data intensive applications, and new approaches, and like things that basically industry has to overcome to manage these applications. But this is about data intensivity. How about data teams, right? And this is also a common topic. And for example, the Data Teams book, the author of which was also presenting here a couple of weeks ago, and uh, MLOps concepts that are like floating around there. So let me just loosely define as a data intensive team as a team for whom running these data intensive applications and data products generally like presents the main challenge in their work, and as well as new architectures for these data intensive applications that arose from the Martin Kleppmann book. We are also needing right now to rethink the way we manage data intensive teams, the way we manage products in data intensive teams, the way we develop data applications, basically. And yeah, generally, if you think about that, like why now? Why now is the time to do that? Then I think I have some bad news for you, and I think that it's partially because of our like a ever increasing desire to want more, to consume more. And in this case, it's like to digitally consume things. So we have very high expectations right now. We expect the search engine to guess what we're going to type from the first symbol. We expect to talk to our phone and for it to understand us. We expect to be present in a digital space and see other objects in this digital space. And we expect to take a picture and to understand what's in that picture straight away. So, and don't get me wrong, this is all great. I cannot live myself without this kind of applications. However, as a developer, as an engineer, as somebody who is responsible for this application, it introduces a whole new layer of complexity because user expectations are extremely high nowadays. User expectations like are ever growing, and we all need to accommodate for that. We all need to uh, create something that will meet their expectations. That's why I think, yeah, definitely it's not a bad thing, but this is something to consider going forward. And so, what are the problems basically with data products, with developing them. And I think that generally there are two. Like first of them is that you need to invest basically upfront, usually much larger investment to make it upfront rather than with the standards, let's say non-data products. And then on top of that, you have a higher uncertainty on the return on this investment. And so right now, I'm going to introduce you two concepts and like two actually heroes, not less, for this presentation. And if you need to remember one thing from this, I want you to be remember this one. So please pay attention on this slide. And here we go. An elephant and a chameleon. So an elephant will represent a larger development investment that we need to make, like because it's a large animal, and like as a happy coincidence, elephant also is a symbol of many open source data projects, well, such as Postgres, for example, or Hadoop. And a chameleon will represent our high uncertainty on this return on investment because it can turn out red, it can turn out green, and we want it green, of course. So, and for this, we're going to focus actually on this chameleon first to see how we can influence this uncertainty, how we can reduce basically this uncertainty in our investment. Cool. So off we go to look at the typical development flow for like a standard in the industry before this, smart data applications. And generally it was like, hey, we take an idea, like it might be highest paid person idea or just like generally great idea, but then like we take this idea and we start implementing. We're developing, writing tests, which is good, of course. Like we are writing documentation, which is even better. And yeah, arguably you're doing all these great things. However, you might end up with not something that is not very much successful. And here's a problem: you were doing like right things, right time, and then you ended up with something that is not good. How did that happen? And yeah, the reason is that this kind of typical flow is generally bad for data products, where success doesn't depend on the code or system quality, at least not solely depend on that. And it's hard to predict results from the initial project planning. As well, it's like optimizes for the wrong metric. You're implementing something and then you're releasing it to the users and get the feedback from them only at the end. So this might be wasteful. That's why to overcome that, of course, what do? You go on Twitter. And Twitter is a great place to see that you're not alone. I mean, also other good things happening there, but generally, for example, you see that, okay, Leo is saying like, hey, actually, the scary thing is to spend 6-12 months of like perfecting your product, developing something, but then realizing that actually you're building the wrong thing from the beginning. Also Tom Chi saying that, hey, actually you can continuously have like, you can have a best system which continuously iterates, like integrates all day long, but then when you test with users only once per 3 months, then actually, yeah, your loop length is 3 months. And you can see like from Danlo, it's also like, it's a problem not only for like, let's say, smaller companies, it's also big companies are struggling from that. And you can see he mentions that AWS has smoked Google in such case from hearing about the product from the announcement, and then it was able to implement it faster. Okay, so yeah, we are not alone. Something is happening. We need to solve it. The way we came up to think about that is actually like a very well-known in the industry, the practice of rapid prototyping and experimentation. And so where do we start this flow? To rapid prototype on something, you need to start with hypothesis. Why hypothesis? Just because, for example, if you start with the idea, then it introduces this potential blame on failure, which will say, hey, actually, like idea didn't work. It was something not necessarily great. Okay, then you create this potentially blame loop, like who wants to develop a bad idea? And another way to call it a user story, for example, it presumes that we know our users, which is like actually quite um, quite selfish, and might be even arrogant at points. So I think that hypothesis is a good name just because it doesn't have certainty in it. It can be right, it can be wrong. It's hypothesis. You start with that, can be right, can be wrong. Very good. So you take your hypothesis and you go off to prototype. Okay, and what do you do like with a prototype? How do you develop? And generally, there are of course no guidelines or golden rules how to do that. But I think the most important part is to do it as fast as possible, and then also decompose your hypothesis up to the point where you spend minimum effort to test your assumptions. And for that, let me give you some examples of famous prototypes that probably maybe not all of them. So you can see on the left, this is a Apple One. You can see it didn't even have a screen or something. And the point is that, yeah, guys from Apple were not like perfecting it to the point where it's going to be like a perfect computer before starting selling it, because it's a prototype. Like you need to get the feedback, and then they got the feedback, and you see that Apple is doing quite good right now, and they went a long path from this prototype. But you can see how it started. All right, and then another famous prototype example is a Google Glass, and you can see like a Larry Page with some I don't know, like roads and tape on them and some sheet protector. And it's like, come on, a netbook. Like I think that half of the audience have never seen a netbook, and but yeah, like this is a prototype. I see, and also like I think that's a great example also because we all know that, for example, Google Glass didn't work well as a project, and generally prototyping doesn't give you like confidence that something will succeed. It mostly gives you a confidence of like, okay, you're not investing into some definite failure, right? Like you don't know if you will be able to get great results from the project, but at least you're cutting your tail, you're saving you from costly failures from the beginning. Another great one is Yandex Navigator, which is kind of Russian analog of Google Maps. And then you can see that actually right there is a like app open, and then on the right, the person is sitting with a metal rod, and you can see that he's stapled like some kind of paper on it. And whenever the time comes, he shows it to the driver to see if it's useful for the driver. So they could have developed differently, right? They have very good programmers. They could have put them to work there and to develop this as a prototype in the application. But why, if you can do it like super cheap and super fast by just jumping into the car and trying to test something straight away? So their idea is to try to get the user feedback straight away. And this brings us to the next point of experimentation, right? Is that you don't develop your prototype just for yourself, for you to have fun. You don't build the POC just to, learn something or anything, but you actually developing it to get the feedback from the real world. You want to go to the real world as fast as possible. You want to get feedback from your colleagues. You want to get feedback from your customers. You want to get feedback from random people you meet on the street. I mean, like in post-pandemic world. And so that's the point. So that you take your prototype and you don't just keep it for yourself, and you don't make assumptions based on what you think, but actually you're showing it to users. You're making it hit the road basically and collect the feedback. And this way you can also avoid costly mistakes. And we actually talk about this, how this can save you some money a bit later. Here, then you end up with something. You collected the feedback. You build your prototype. You already have some data. And basically now, and only now, you're ready to productionize your things. Now you're ready to make an investment of the engineering effort, of the like a team effort, of company effort into something, because you already know that you're maximize your chance to be successful, you already know, for example, a ballpark of how much the thing can bring you. And then this means that you already know how much you can invest. This means that you already know how much you can spend on the maintenance. That means that you already know basically your budget for the thing. And yeah, generally on each of these steps, you don't need to go the full cycle here, right? You don't need, if you're taking a hypothesis and then start building a prototype, you don't need to go full cycle for the productionization. If you see that actually it fails at some point, if you see that prototype is not successful or experiment didn't bring enough uplift, or you just got bad feedback, and that's great, because this way you just abandon it, or you go back and you adjust your hypothesis, or you just take a new hypothesis. And this way you actually can maximize your time to value. This way you can actually short circuit like this this framework and go to time to value much faster. And if you think about this, each of the following steps is not equal, as a box in a previous slide. It's not equal in effort. It is not equal in cost of implementation. It's much easier to hypothesize than to implement something. It's much easier to make a prototype than to productionize it. It's much cheaper to make an experiment than to develop something full steam on. And that's why your potential savings are actually much higher on each of the steps. So like you actually can earn by failing, like this is a meme of Silicon Valley, that actually they're always looking for founders who failed as much times as possible. But you can see that this can potentially and partially be true, because you earn by failing. Actually, of course, not by failing, but by converging to the working solution faster, so that you're discarding all the ones that have potential flaws in them, and you invest into something that is really, really promising. Cool. So we are doing the Chameleon's recap, and it is like that. We have a constant flow of hypotheses. We always hypothesize. We minimize investment into our first prototype. We never develop something unless we are sure that this can be workable, with this can be doable, and this can bring something to our users. And then we collect the feedback from these users, the real feedback. We invest engineering effort into something that has proven its potential and has a possibility to become good. It doesn't mean it will become good, but at least we really, really tried our best to reduce this variance and to make this Chameleon green instead of red. Cool. Now it's a quiz time. Do we have prizes for the quiz, Alexei? I think we can have some. Who remembers the second animal that was there? Drum roll. It's an elephant. Cool. So now we're gonna look, by making Chameleon green and happy, now we're gonna look into this beautiful elephant and try to make him happy. Try to make this larger development investment better for us as an organization. Cool. So we just talked about Chameleon. We talked about like making things faster, building things faster, iterating faster, failing faster, basically. What's wrong with just moving fast? And for this, I'm bringing up on a stage a person who knows a thing or two about moving fast. Actually, I think that Facebook definitely made this as a part of a pop culture of moving fast and breaking things. However, there is a lesser known fact that actually right now they changed their motto, and I mean, not right now, but a couple of years ago. And right now it's not move fast and break things, and it is move fast with stable infrastructure. And so, yeah, like you see, this is a subtle transition. So we still want to move fast, but we want to protect our tail. We want to cut our losses again. And okay, like I get, like Facebook, big company, like maybe rules are not applying for all of us. But let's look at some example from the real life. Well, as much as professional football can be real. But I'm bringing Thomas Tuchel to the table to get some wisdom from him, basically. And for those of you who are like not aware who he is, I will tell you straight away. So you can see the image, and then on the image you can see that this is potentially the most expensive player in the world, and this is Thomas Tuchel. So the person who is not afraid of doing that, I think at least he is worth listening to. And yeah, generally he is a coach. I think right now he is a coach of Chelsea. Before that, he was a coach at Paris Saint-Germain and Borussia Dortmund and other teams. But once I read an article about him, and there I saw the following quote. So basically, he's talking about attack and defense. And about attacking patterns, he's saying that, okay, we show these patterns on video, but we don't practice them much, really. We almost exclusively concentrate on our defensive movement in training. So, and then attack arises from different patterns, different times, against different opponents. And at first, for me, this was like, why would you do that? Like, you have such great offensive players, such great attackers, and like, why do you only practice defensive movements? But then, when I loosely translated this in my head to the language of technology, I got something like that. So that to be afraid to experiment and attack, meaning exploring new opportunities, you need to have your defense solved. So that meaning you need to solve your infrastructure and ops, so that this builds a foundation from which you can actually go forward and not be afraid to experiment. Okay, so how does this map into what we just talked about in a chameleon elephant case? And then again, I think that we still start with experimentation. We start with prototyping. We start with something that is like a real, in a real world. For example, yeah, it's totally fine with starting your ML journey by building a popularity-based model trained on CSV files that you got from some FTP server, whatever. Uh, it might be like a group by query, if you wish, which gets popular items like users or whatever your business is. But you take this one and you don't go forward unless you actually put this as a data product in your production, meaning like unless you exposed it to your users, unless you build like this full cycle already, and then you got the user feedback, and then you're like, oh, actually this is maybe not what I thought, maybe this is not what I'm expecting. But during that phase, you will also discover lots of internal needs. For example, you learn that many components are missing in your system, and you will understand priorities of those. And yeah, you will know what's worth investing and what's your budget. So you'll say like, hey, actually, I got the feedback. I see that potential ROI. If we can make it better, might be X. Then you know that you can spend Y, for example, investing into your platform, into your foundational layer. And that's exactly what you need to do next. For example, when you have this one popularity-based model running, and then it's good, it's bringing some results, think about what would you need to do to run 10 of them, run 10 models smoothly. What would you need to do? Maybe like some smaller like feature store, or maybe some automation layer, or like a scheduler, whatever, like automatic data checks, whatever is there, you will see it. And the good part is that you will see it from your like a first own experience, from hands-on experience, from the experience of your team. And generally, it's also good to think about products like that in a 10x way. So this is a 10x. Many people are saying similar things in the industry. So this is like not a magical, statistical, whatever number, but more of empirical. And I'm hearing it from some other folks in the industry as well, that when you're building a system, it should survive a magnitude of scale. Because yeah, also like logically makes sense. If you're building something that can survive 100 times scale, then probably you overinvested from the beginning. On the other hand, if you build something that can survive only like 50% scale, then yeah, maybe you will need to rewrite too often in the ideal case. So we're thinking about, okay, what do we do to run the 10x system? The beautiful part of that is that actually this is a very, very like a long and time intensive project. For example, you want to build the first iteration of your feature store or mail platform, and probably it will take 6, 12 months. Uh, but at the same time, while you're doing that, investing there, you don't need to stop because you already has built this cycle into your product where you can play with things, you can learn from things, you can iterate on things, and basically make your user experience better at the same time and learn something on your own. And probably you will learn more that you actually your requirements that you set in the beginning were not entirely precise, and then maybe you need to change something. And this is great because this would be the time where you would need to invest again into growing your system, and you'll be ready to do that because you'll again have real requirements, not carrot culting, not something that, for example, you know that, okay, you've heard that Google is doing some ML, okay, and you've heard that they're like having a full-fledged ML platform for that. Does it mean that you need to build ML platform? Well, maybe, but like it's like asking, for the best move on a chessboard. And then, like, if I don't know, the Petrosan has made a movie 2e4, then everybody should do the same move. No, it's like everybody's move should depend on the situation on the board, right? Everybody's move should depend on your current situation, and that's the best part of it. That you will have your real feedback. You will have your feedback from users. You'll have your feedback from engineers, and you can incorporate this into requirements of this longer term investments of the foundational layer. Oh, yeah, and you never need to stop, right? It's like hopefully you always grow. Hopefully your business prospers and your team grows, and yeah, you continue experimenting, you continue building, you continue evolving to infinity and beyond. So, elephants recap. So, infrastructure and operations are the most important things for the innovation. And that's like a counterintuitive part, but I think that this is a crucial and important part. That if you want, as Thomas Tuchel is saying, like if you want to have really great attacking play, you fix your defense first. Then you build your system to survive at least an order of magnitude of growth, and then you build systems based on your requirements from the users, from your business, from your developers, not like cargo culting or anything like that. And at this slide, I really want to thank you all for your attention. Basically the idea is to get this two together, to get a chameleon, to get your elephant, put them together, and yeah, basically for data team or any other team, have fun, enjoy the process, learn while you're doing so, and thank you very much. I'm also working on a book called Hypothesize. You can pre-order it here, and I'll be happy to connect with any of you and discuss more questions. Also, we are hiring as a last bit from me, and also we'll be happy to discuss potential opportunities. Thank you very much.
Thank you, and don't forget to follow Elias on Twitter.
Thank you very much.
Yeah, thanks a lot. So I just want to remind that if you want to ask a question, there is a link pinned in YouTube chat. So just click on this. It will bring you to Slido, and there you can ask any question. And in the meantime, I do have a couple of questions. So in your opinion, at which point a team becomes data intensive? Like, is there a moment when a team is not data intensive and then it is? Or like all teams are data intensive from the start?
Yeah, I think actually it's like not all the teams are data intensive from the start, right? But there is a very, very subtle point where you have a potential to be data intensive, and then you almost straight away become, because I think that even as I'm mentioning, like even a small group buy on your data and showing some aggregations to users, I think it's already data intensive product, where you just don't need to show something as you planned, but actually where what you're showing is based on user action, is based on some other pre-aggregated data. That's why I think that, yeah, more and more teams will eventually become data intensive.
Mhm. Okay, and so to me, this motto, Facebook's motto, "Move fast, break things," it really resonates with me. So I try to always do that, but often I
Mm-hmm.
meet resistance from developers. Like they start saying, "Oh, but like it's not solid. There is no
Mm-hmm.
95% test coverage. It's not good." And
Mm-hmm.
like a lot of resistance from shipping something that is not even not perfect, but bad quality.
Mm-hmm.
And this resistance is very difficult to fight with, because I think this is like some sort of a paradigm shift, right?
Mm-hmm.
So in your experience, how do you overcome this?
Yeah, that's a great question. I think indeed it's happening, and indeed it's happening just because of the shift in the paradigm on how we develop things, on how we think about development in general. Like, yeah, what we are doing, for example, we have this like framework of the hypothesized flows that I just showed before, is that, and then like there is this contract and there is this explanation of whenever we are prototyping with something or experimenting with something, we are not developing a real product. It shouldn't have like a full test coverage. It shouldn't have like a like full documentation or things like that. Just because we still don't know if that's a worth investment. And this way, like also showing this diagram, it already helps to set the structure and framework in the head. Like, okay, actually, I'm like in a prototyping phase. Okay, I'm not gonna invest too much, and I'm not gonna be like requesting from others to invest too much here, just because I know that we want to test as fast as possible. We still want to learn. However, I think that this is also important point that whenever we go to the last part of productionizing thing, and then when you learn, for example, something works, now we need to make it good. And this is the important part as well, not to forget to say like, hey, yeah, we were really, really fast in prototyping. Now we need to slow down a little bit to actually productionize the thing, to actually to have a good test coverage, to have good documentation, to really make a solid product out of that.
Mhm. Okay, so basically you accumulate some technical debt, and then at some point there is time to pay this debt, right?
Yes, yes, very good definition.
Mhm.
Yes.
And do you somehow try to keep track of all this debt, or maybe it's just easier to completely rewrite the whole thing?
No, like we don't have any specific process to track the depth, but it's more like whenever it's experiment or something, yeah, it's fine to go fast, to discard things, and whenever it's production, we now really have like a checklist and things around that to to make it at least of a
Mhm.
decent and above quality.
Okay. Maybe do you have some recommendation for people to start practicing this rapid prototyping? Like how can they learn this skill? Because it's also a
Hmm.
skill, right? So because we were taught by all these books that we need to be careful, we really need to produce great code with like following all these practices. So is there a way to, set like somehow lower our standards and in and sacrifice them to move faster? Like how would you advise people who want to learn this to
Hmm. Yeah, I think that's a great question as well. And generally, I think we all, like as humans, we learn from example, right? Like from the very young age, we look at examples and then we learn. So I think that also like showing these examples, showing that uh, okay, like it's possible to do faster. It's possible to not to invest from the beginning, and then also like urging our colleagues, urging ourselves to think twice. Like, okay, is this a hypothesis I want to like invest, or maybe I can decompose a little bit. Maybe I can test it cheaper. Maybe like something that I want to learn, I can learn without writing any code.
Mhm.
Maybe something I want to learn without writing like 100 lines of code, I can write with one, which wouldn't be perfect, but would be good enough to improve my understanding, basically to reduce my assumptions.
Mhm. So basically, you're saying uh, to try to avoid writing code and try to test as small thing as possible, right?
Yes. So like whenever possible, like showing examples on how this can be done, and also reducing initial effort, thinking twice before writing, but actually try to minimize the time
Mhm.
you write, you build before going
Mhm.
live. And yeah, like this can be a prototype that you show to your colleague, and his feedback is already user feedback, right?
Mhm.
This is what you want to do.
Okay. Yeah, which also reminds me of a discussion that we sometimes have is this build versus buy. Like, should we
Hmm.
invest some time and use some kind of vendor to
Hmm.
try their services before building our own model? Like usually,
Hmm.
like now there are so many different startups that do deep learning, machine learning, like as a service. Um, so, in your opinion, when does it make sense to try a vendor, and when does it make sense to try to build something ourselves?
Yeah, I think that's a very valid question, and it's also like I would say doesn't go too off the track from this uh, framework, let's call it, because like okay, you always need to know what's you're trying like to achieve. Okay, for example, you want to try a new vendor. Why do you want to do that? You want to develop some new feature. Okay, then can you do it in house? Well, it will take some investment. Then can you buy it from somewhere? Like yeah, actually we can do it super quickly, but then maybe it's still like can you maybe ask three people in your team for an hour to, I don't know, to manually tag images or like answer people questions in a chat, and then maybe you can even do it cheaper without any vendor, without any development from your side. Like it,
Mhm.
always try to decompose till the end.
Yeah, I remember sitting once with my product manager and just labeling things. It was
Yes,
fun.
yes, absolutely. It's
Yeah.
also label like some search queries.
Yes,
uh,
exactly. Yeah,
yes,
we
all
have a
the
few
team.
questions. So everything you mentioned seems true for any product in the world. Is there anything particularly important for data-intensive product?
Well, I'm not sure if that's actually valid for all the products in the world. I think that, for example, like financial products or like I don't know, insurance or health, they are quite different in this sense. You cannot allow yourself that much. You often, or like a airspace industry, like flying to the moon. It's I think that we are privileged actually in this data intensive world, that we can go like as fast we can yeah, break things, we can experiment there, and this is like potentially has lower impact on users lives. But yeah, generally this impact increases with all the news, with government using face recognition to track people. So the more and the more we go forward, the more we'll see basically more restrictive frameworks on our work, and yeah, introducing standards, things around that. But yeah, generally I think that yeah, my point is that the data products are still where you have uh, potentially ability to play with that. Well, actually, it's not really that true for many industries.
Mhm. Yeah, I was imagining if, let's say, Boeing or some other aircraft manufacturer would decide to run A/B test on their autopilot, right? So
Yeah,
they
it's
don't do that.
yeah, but yeah, I think that they have like a controlled experiment still, but like in a different manner, and their cycle is like very much different from ours.
Yeah, actually, two people ask if you can share a link to this to your book from the slides. So how
Yeah,
can
absolutely. I'll share slides.
this is on your
Alex.
website, right?
Yes,
Eliasnema
you can
dot.
also go to eliasnema.com, and then there will be a
Yes.
description
So
of it there.
what I'll do right now is I'll just put this to the chat. So Agnes is listening right now. So she's
Hi, Agnes.
okay. I just saw her message in YouTube channel, in YouTube chat. Okay. Many different products share same assumptions. Should hypothesis checking then be done separately from products to prevent doing the same work multiple times?
Sorry, like I'm not sure if I understood correctly. So,
okay, so let's let me try to. So many different products share same assumptions. Um, yeah, so I'm just wondering, what assumption do you have any idea what these assumptions could be? No?
like, yeah, I don't know. The easiest assumption is that we want to develop features that everybody will love.
Okay.
And then,
Yes.
yeah,
So
you
let's
don't
say
actually
two
know that.
different products have this, but maybe let's say two different e-commerce products can have assumptions that a recommender system will boost some sort of metric, right?
Okay.
Should hypothesis checking then be done separately from products to prevent doing the same work multiple times?
Well,
Maybe like
might be
extracting it.
possible. Yeah, I think there is a potential there. Actually, great idea. But yeah, you should also. I think this is where you need to be very careful with your sample, right? Because different products might have different users that will behave differently, and then your assumptions might be, yeah, even for the same hypothesis, you might get different results at the end, just because, yeah, like for one product you have audience of I don't know, people from 20 to 30, and then for the other you'll have a older audience of some sort, and then their behavior will be actually different, and then what they want from the product will be also different. That's why, yeah, I think that it has a potential, but yeah, you need to really be careful, even like maybe not even with similar products, but with similar audiences.
Okay, so basically, if something works for Google, it doesn't mean it will work for you, right?
Well, yeah, that is for sure.
Even if you have the same product, like if it's I don't know, DuckDuckGo search and Google search.
Yeah, I mean, yeah, especially for them, I think that also they have a very, very different audience,
Yes.
DuckDuckGo and Google, and also they have like a different resources and so on.
Yeah, probably DuckDuckGo is run by a small team, and they
Yeah, I think so. I
yeah,
think so. But yeah,
and Google is
I've,
a super large corporation.
yeah, I've heard actually like Apple talking to DuckDuckGo, thinking about their independent search
Okay.
engine.
So we have another question: is should prototyping and production development be done by different teams? It feels like the process requires different skills and different approaches.
Well, I think that it depends really on your organization structure. I think that both can work, but I'm personally a huge fan of like a dog fooding. I don't like when some people are just working developing prototypes and some people are just implementing them, because this like disconnects both of them from reality. Disconnects people who develop prototypes from like production reality, and then production people are disconnected from real users.
So it's like this problem that, like, let's say when you have a separate team of data scientists, they're doing something, developing cool prototypes, and then it's a code in R and something, and then they tell data
Yes,
engineers
yes.
or here is like, please, our management is happy, they want to see it in production tomorrow. Please do it, right?
Yes, exactly like that. It's a classical example, I think, and yeah, still super valid one. That you need to understand constraints of people and constraints of systems, basically to make something work in synergy.
Yeah, which also like I don't know if it's related, like these topics of data ops and ML ops, because this is what this DevOps and something ops, this is what they advocate, right? So it's like this functional team, everyone is sitting on the same team, and they have shared responsibility. So how, in your opinion, the data ops is related to the thing you presented?
Yeah, I think it's it's a great movement, DevOps, MLOps, and I think that DataOps recently, like all of the things are general continuation of basically our applications becoming smarter, our application becoming more complex, and yeah, I'm happy to see this movement going forward. But still, I see them as a more of a tooling. So whenever you want to make something working smoother, something working more autonomous, you go there and you think about this as a tooling, and yeah, like you don't necessarily need to start with that. You basically need to start with something that you can quickly prototype on your
Mhm.
laptop and then try to get the feedback. And then after that, whenever you already have something working successfully, now it's time to now it's time to think about the better process.
Mhm. Okay, which yeah, I think you touched that point in your presentation when you
Hmm.
suggested, like, let's say when we want to build a recommendation system, so first just do a popularity-based thing, then see how users react, and then start building infra around this. I mean, start building extra features like
Yeah,
maybe feature store, whatever, but you already have a working thing that is bringing value to the user, and then
right.
you add these things after that, right?
Yes,
So.
that's I think that's a valid example, and like not only for recommender systems or whatever, but the classical approach you see on Kaggle even that they ask you to first do something very simple with a popularity based or just like a statistical based, and then and try to beat that. Unfortunately, this often happens like in offline. So people try to improve and improve and improve the model offline. But actually, I think that the sooner you put it there, the sooner like it can be the worst thing possible. But you put it there. You have this cycle with the user, and then you can improve this cycle.
And yeah, so for that, you don't need data scientists at start, right? Like when you just, let's say you just start in a team, like
Hmm.
you don't need a data scientist or any, like you just need an engineer to implement this
Hmm.
popularity-based thing, right? So at which point you think a team needs a data scientist?
Well, that's a good question, and I think that it also relates on whom do we call data scientists, because
Mhm.
in the industry there are so many standards for data scientists. In some companies they are more analysts, some companies they are more research, and in some companies they do like everything. So yeah, depending on uh, who do you think the data scientist is,
Mhm.
it will also like answer this question. But generally, I think if you like think about more of a research type folks for data science, then probably uh, yeah, you need to introduce them already when you have like at least 10 models
Mhm.
running. And
And by models, you mean like these simple, I don't know how to call them, heuristics or like simple
yeah,
methods of.
yeah, like 10 is again like just a word from the top of my head, but it might be one, but you already did like a 10 iteration on it. Like so whenever you are more already sophisticated in the process, whenever you're more like you know the data flow, you now know what's the impact, you know what do you want from it, you know where do you want to actually fine tune things.
Mhm. And for this case, like when you're just starting a team, who do you need to have in the team to to lay the foundation,
Hmm.
like build this elephant, so then a data
Hmm.
scientist comes and can be this chameleon and
Hmm.
experiment. Like I guess you need an engineer, a product manager, who else?
Yeah, it depends, I think, from team to team, but generally, of course, you need to have a very good infrastructure, like system
Mhm.
engineers or like DevOps. It's also many names, same as data scientist. Then you have like a probably data engineer, like or like a backend engineer who has a strong data background as well, knows about pipelines and things around that. Yeah, also like it might be depending on the team composition, might be one or more like backend slash data engineers. Then I think that you need to person with analytical skills, right? So it might be data scientists already, but then like most of the initial pre-work would be like more like understanding users, running like queries and understanding where do we stand right now, what can we like what are the low hanging fruits we can pick.
Mhm.
So I think that this is a like a potential foundation.
Okay.
for the team.
So just to summarize and make sure I understood correctly. So first you get an engineer, a data engineer who builds the data infrastructure, then an analyst who can analyze and understand, well, it can be a data scientist, but somebody who performs this analytical, who's doing analytical stuff to see what are the potential, how our product is doing, and only then data scientist comes and starts building machine learning models.
Yeah, like something like that. But then again, like this analyst can be a data
Yeah,
scientist in
of
some
course.
companies.
Yes,
Also, you
yes.
missed, I think, a system engineer in the beginning. So
System
that,
engineer, yeah,
yeah,
exactly.
yeah,
So
we
together with a data
yeah,
engineer.
yeah. I think this is important to build this foundational layer
Mhm.
on which you can further iterate.
Okay. Now we have another question. What is your recommendation for startups to start hypothesizing and learning when sometimes we don't have enough traffic to learn from experimentation?
Yeah, but that's again like you don't need traffic to experiment. Your buddy is sitting right next to you. This is your best user. You like a try system on him. Like this is something that, of course, it's great when you have loads of traffic to run experiments. If it's a booking that runs like thousands of experiments simultaneously, uh, but yeah, generally this is not a requirement. You can already get the feedback uh, from from just listening to single data points. Of course, it might not be statistically significant, but it will give you a hint of like whether your assumption. You start with assumption like that. Then you're like, okay, cut it in half, then cut it in quarter. Then you're like, okay, there it might be something here, and yeah, generally, I think that the uh, biggest lies is that you need lots of users to do experimentations. You don't. You can do it with 10 people or like something
Mhm.
in this ballpark.
Like what was this experiment that Yandex did? I don't think I understood. So they just put sticky notes on the phone to.
Right. So they opened like a navigator, like a maps, and then like a driver was riding, and then another person sitting next to him. He was putting like stickies on his phone when the time was appropriate. For example, like okay, you want to turn right, and then instead of writing coding this feature, he was just showing, hey, turn right, something like that. So they wanted to test as fast as possible. You see, you need two people, right? And uh, yeah, you can already learn something. Of course, it's not 100% mapped to what's going to be the final version, but at least it helps you to reduce your bias because maybe you are in love with this feature.
Mhm. Yes. I hope there were no accidents because of this second person was, putting stickies on the phone.
I hope so.
Okay. Yeah, I think yeah, we still need to have a short break. Yeah, thanks a lot, Elias, for coming and sharing your
Thank you
knowledge,
very
your
much.
experience. And do not forget to follow Elias on Twitter, check his website, and there will also be a link to his book. And yeah, so the next talk will be from Susan, and she will join soon. So now we will have a short break.
Thanks for having me. Bye bye.
Bye.